Hey guys, it's Miss Kennedy. It is time for our Encounter 1, Erosion, Deposition, and Weathering. This relates to Standard 6.1. So again, this talks about how erosion, deposition, and weathering affect Florida. So make sure you're able to compare and contrast those terms. That's level 2. Make sure you're able to compare those to Florida. That's level 3. So go take those concepts, apply them to Florida. And then level 4 is, so the A level is to take these concepts, erosion, deposition, and weathering, and actually apply them to use the concepts that you learned through Florida and apply them to other places. All right, so let's get started. Let's talk about weathering and really weathering. So what weathering is just really the breakdown of rock. So if you take a look at the picture that's presented in front of you, you can see that all it is just breaking down rock, breaking down it into other substances. There's no movement, there's nothing associated, completely just weathered rock, weathered substance, okay? Erosion, the difference between weather and erosion is that erosion actually, though it takes the broken down rock and it moves it to other places. So check out the picture. Look what's involved in that picture that's different from the first. You see that it's actually raining, there's precipitation, okay? Water is a form of it's an erosion agent. So pay attention to that. Look where it's moved the rock, okay? Look at the incline. Let's talk about erosion a little bit. Now, this is going a little specific, but just to let you know, there are 3 parts of erosion. Detachment, so it gets lifted away, so you detach from the bigger rock. It lifts those particles, so in other words, it's traveling. That's part of erosion, or excuse me, it's lifting them up, and then transporting it, which is actually moving those particles, okay? All right, so there's really 2 types of weathering. One, physical weathering, which is also referred to as mechanical. So if you see those words on the FSA or you see them on the summative assessment, make sure that that triggers physical weathering. And there's also chemical weathering. And you know Miss Kennedy's favorite subject is chemistry, so we'll talk lots about that. All right, let's talk about physical weathering and what it is first. I cracked myself up. Anyhow, okay, so physical weathering is literally just where its rock is physically broken down into smaller pieces. There is absolutely no change in composition. So in other words, you're not going to change form. You're not going to change one substance into another. There is no chemical reaction that takes place. That's simply what a chemical reaction is, BTW. Okay, is whenever you change one substance into another. You have reactants and then you have products. Not on the test, but I know you'd love to know it. I know. All right, now, there's different examples. There's different things that happen with physical weathering, okay? Your book talks about them. It actually lists as only 5. I have 6 given to you here, but just to keep you in the know, give a visual, think about it, okay? The first thing we have is abrasion. All right, the first 2 pictures up top. So let's take a look at those. One, you can see that there's a glacier. And it's pretty much melting away, but it's also, you can see what's been left as a result of the glacier. People think, again, that glaciers are these soft, fluffy little things. They're not soft and fluffy. They're ice. Water is pretty heavy when it becomes a solid, actually. So why ice float? There's a density, not a density change, but, well, that's here nor there. Anyhow, let's talk about the other picture. The other picture is actually physical abrasion. You can see, do you think it actually began to look like that? Or was that caused by wind and actually erosion? So other sediment actually hitting that rock when the wind blew. Think about that. Okay, I don't believe that hole was there to begin with. I think it fell away. Okay. Talk about frost wedging. It's exactly what it sounds like. It's like a wedge. So when you put a wedge underneath the door, okay, and it holds the door open, think of like the wedge as water, and it's going to fill in the crack. The water is going to freeze, okay? When you freeze, exactly what happens in with water, that's why you don't overflow your ice trays, okay? It expands, all right? Same concept there, so you can see the actual crack on the frost wedging expanding. All right, let's take a look at these wonderful things. I put them all together. You've got, let's talk about plant roots. Pretty cool situation underneath ground. Wish we could see it. We did see a lot with the hurricane whenever the actual hurricane by wind, which was erosion, okay, but that was not the process. Like, think about what we learned on our quiz today. All right, think about all those plant roots that we saw in the ground and how it built the trails, the creatures, all those things, all that bugs, all that kind of stuff that lives in those plant roots. And it's actually like sort of kind of like the frost wedging. It's making its way through ground and it's breaking things apart. Okay, that's actually weathering the soil away. It's making crevices. All right, your book specifically talks about pressure change, but however, just to let you know, pressure and temperature are really one and the same. As temperature increases, so does the pressure. Okay, and I like to always use the example of a tire because I always think about that on a hot summer day in Florida, and or even today. It was pretty cool today and yesterday. Think about if your parents' tires in their car actually showed that they were beneath the level in which they were supposed to be kept. So there was a signal going off in their car. I actually had one, okay? But I went to go to the car today, and it's not there anymore when I left. So just letting you know, so as temperature increases, so does the pressure. All right. So in this place, you see pictures of a fire, and you also see cold. Okay, so think about the expanding of joints in a home, like whenever it gets cold and hot outside, when new houses settle. It's the same concept. When you see the gaps between, if you had a tile floor and the baseboard that runs across it, and then sometimes you'll see a gap over time. Okay, so the wood actually expands and contracts. Let's talk about those animal actions. I don't know what animal that is. I found this cute little picture. Of course, it had a little baby in it, so of course I'm going to put it in it, okay? All right. All right. So, and those little animal actions are not always too kind to us. Sometimes they get into our, underneath our, we've got, we had raccoons at our house. There's possums, armadillos, whatever those little suckers are. I don't know what they are down in the picture, so don't quote me on anything. All right, and then there's gravity. Obviously, you can see what gravity is trying to show you. It's the presence of actually falling rock. So physical weathering when something falls. So abrasion happened. Back up to abrasion. I'm sure there was rock due to gravity that fell. Okay? All right, let's talk about chemical weathering. Chemical weathering is when you actually change within that rock. There is actually a change in the bonds, the way they are held together to create something new, okay? So chemical weathering is actually a change in the substance in a way. All right, so really there's 3 processes. Your book talks specifically about 5, but I've really condensed them into 3, but they're really there. So let's have a conversation. Oxidation, okay, it's just like the word ox, okay, think about oxygen, okay, it's when oxygen reaches that rock. So in this picture, you see that there's actually a discoloration of the rock. Oxidation, for example, we see chain fences, when iron is in the presence of oxygen, you're going to create rust as a product. So there's your chemical reaction right there. So iron plus oxygen produces iron oxide. Iron oxide is just the formal name, the chemical name for rust. Okay, yes, it will be in the presence of H2O, water vapor, all that kind of good stuff. Remember, we learned about the atmosphere and the water cycle and all that kind of stuff too. Hydrolysis, think of the word hydro, okay, water. Hydrolysis is whenever water gets to a rock. This is what makes rocks permeable, okay. Permeable is when you have those small holes and it breaks apart the rock, all right. Obviously, the more water that gets to it, the further the rock's going to break apart. Hydrolysis. Carbonation. So really carbonation comes in acid rain and carbon dioxide really, but really acid rain. Okay, acid rain, now there's not sloughs of it. We're not going to die if we get rained upon. No, you're not made of sugar, so don't think yourself lucky. Okay, I know I am, but just not you, not yet. Anyhow, but think of the acid rain, and really that actually has to do, and there's little bits, but that's actually affecting the composition of that rock and breaking that down over time. All right, so let's circle back down to, we've talked about erosion, we've talked about weathering, the difference between those two. Let's talk about deposition. Deposition is a lot like the word deposit, okay? So think about the concept of like sediment, soil, and the rocks actually depositing down, okay? So if we take a look at the picture, some examples of landforms that will form are deltas, floodplains, sandbars, and dunes. So in my next encounters, I'll talk about those specifically. But for right now, those are things that should be associated with deposition. So when you're looking through your cookbook, in the back of the cookbook, it asks whether you have deconstructive or constructive processes between your ingredients. Think about the concepts of erosion and deposition in order to put those things in list. Take a look at that picture, guys. The picture really explains a lot. Remember our examples of the boulders and the sediment today in our class when we were reviewing the quiz. Look at those big rocks. Technically, they're gravel size. We don't have huge boulders going on there, but think of those falling down and what the flow of that river. As you decrease in velocity of that stream or that river, you're going to see things starting to deposit. Okay, obviously your heavier stuff's going to deposit first and your lighter stuff's going to be carried out further dependent upon the rate of that water. Okay, but it's a good visual for you to at least look at to decipher between the boulders versus the sediment and that graphing equation on our quiz, just to give you a heads up. All right, so that's the end of our encounter 1. I will do encounter 2 in a little bit.